Hi, welcome to our first level 1 chance and data video. We're going to introduce some key ideas about probability. In mathematics, probability is used to investigate chance, how likely or unlikely an event is to occur. It is measured on a scale from 0 to 1, 0 being an impossible chance, 1 being certain. And we can have events anywhere between the scale that are either unlikely or likely. Anything that is in the centre 0.5 we refer to as an equal chance. Things like getting older is certain to happen. Getting ahead when we flip a coin, the theoretical probability says it's an equal chance. And winning lotto, very, very close to impossible. Now, probability can be written as a fraction, a decimal, or a percentage. And it cannot be greater than the number 1, or 100%. So, take a look at some examples. Here, anything that is less than 1 or less than 100% is okay, but anything greater than 1 or greater than 100% is not okay. All right, well, let's talk about theoretical probability. That's the probability calculated based on the theory of what should happen if an experiment was to be conducted. We often use the following formula to help us calculate what the theoretical probability is. You might want to pause the video and copy down this rule. The probability of an event is equal to the number of favourable outcomes divided by the number of total outcomes. Here's a couple of examples. In a class of 24 students, 15 are male, 1 is a female, and 1 student is non-binary. What's the theoretical probability of selecting a student at random and that student is a male? Well, here's our rule. Probability of an event is the number of favourable outcomes over the total number of total outcomes. The event is choosing a male. We have 15 favourable outcomes, 15 males. We have a total of 24 students. So the probability of selecting a male is going to be 15 out of the 24. That can simplify down to an equivalent fraction of 5/8, which can be converted into a decimal. Remember, top number divide bottom number turns it into a decimal, and then we could multiply it by 100 to turn it into a percentage. All of those answers are perfectly fine to solve that problem. Right, here's example 2. What's the theoretical probability of selecting a letter at random from the word mathematics? And the letter is a vowel. Here's our rule again. The event we're trying to find is selecting a vowel. Remember, a vowel is A, E, I, O, U. Well, we have 4 favourable outcomes. There are 4 vowels in the word mathematics, and there's a total of 11 letters in mathematics. So we could write it as a fraction 4/11. Now that can't simplify down, but it can be converted into a decimal, top number divide bottom, and it can be multiplied by 100 to get 36.36% if I rounded to 2 decimal places. If all the outcomes have the same chance of occurring, then we say they are equally likely. Here's an example, flipping a coin. We assume the coin's made fairly and each outcome has the same chance of coming up. So we assume both heads and tails are equally likely. So we could say the probability of heads and the probability of tails is both 1 chance out of 2. What about rolling a die? Well, again, we assume the die is made fairly and each number has the same chance of coming up. So we assume all 6 outcomes are equally likely. So the probability of each number should be 1 chance out of 6, according to the theory. What about selecting a card from a deck of cards? You need to remember there are 52 cards in the standard deck of cards. If all the cards are being shuffled well, each card has the same equally likely chance of being selected. So the probability of getting the Ace of Hearts is 1 chance out of 52, which is the same as probability of getting the Queen of Hearts. And the same with marbles. If we talk about marbles in a bag, we assume it's equally likely that we put our hand in and we get a marble, so the probability of each of those colours will be 1 chance out of 5. Right, well that's our first video, so thanks very much for tuning in.